Okay. All right, welcome everybody. We're moving to chapter 3 of Logiciel. It's about conceptual embedding. So I thought last time talk was because we kind of went through all the classic topics related to word computation, and by the end of it we really got to like the essence, and it was nice. Andrew, who is a mathematician, was here and should show up eventually. We kind of said some things which aligned with my reading of the sort of type theory and what Cavia is trying to say here, linking it with the philosophy of computation. So I thought sort of recap, because part of the kind of goal of this whole conversation is that Himanshu found this book and got me to read it, and then it had a very big impact on me that I'm still sort of trying to work out. So it's almost like figuring out why it is that this had such an impact on me is part of the reason for this whole thing. But there's also like, it's a short book that has a lot of ideas in it, linking to analytic philosophy, continental philosophy, logic, mathematics, and a little bit about philosophy of mind. Would say I'm less convinced that this kind of thing will help with philosophy of mind, but maybe it will. And in the back of my mind, there's some loose kind of analogies that one could make with neuroscience, but that's as far as I can go with that. So this is sort of a summary of where the book is, as where we've come so far in this conversation. That so Cavia, not just him, but other people, including someone named Brian Cantwell-Smith, who I mentioned to Cavia on Twitter, and he hadn't come across it. So even people who study this topic don't actually necessarily hear about people who are in the space. But Cantwell-Smith also seems to care a lot about semantics in computation. So this view is that the standard perspective on computation is not satisfying for some reason. And the way I put it, which is not necessarily how they put it, is that it doesn't actually capture how people use or design computing practices. So the standard perspective labels it Turing orthodoxy, which is like that the idea of computation that we've derived from mainly Turing, but also via the equivalence with Church and with Gödel numbering, recursive functions, is that computation is meaningless, rule-guided symbol manipulation, and that if you want to cash out meaning from a computation, that comes sort of from outside the actual computation itself. And we can argue that forever, just the semantic, like just whether we should use the word computation for something with or without semantics. And we kind of did that last week. So I'm saying, so I was like, well, yeah, I guess if you really like Turing orthodoxy, I can't necessarily convince you to dump it. I don't think I have the arguments for that. So we could accept that, but as you know, for instance, Saurabh was saying, and which I think is true, is that having framed computation in a way that is almost indistinguishable from causality or from physical mechanism, you can then argue that the universe is a computer, or everything is kind of, and people have done this for a while now. And then ironically, the one thing that people often agree, or at least we agree, other people don't, I shouldn't say that. We often agree in this circle that calling the brain a computer is not going to help much, except in the trivial sense that we use differential equations to model it. And at some level in the abstraction, people can add numbers and do logic, which is sort of useless because people knew that anyway. So if you really don't like the idea of trying to have a philosophy of computation, what I offer is that think whenever I say computation or when Cavia does, what he's actually talking about is computational reasoning, which is anyway what's on the title of the book, or pragmatic computation. This word pragmatic is kind of a magic word nowadays, and like you slap that onto anything and it suddenly becomes like, I'm okay, I'm down, tell me about it. In many philosophical circles. But yeah, that's basically what it is. But what's interesting is that Cavia has these pointers to more ontological and even political implications. So the sort of boringness of the word pragmatic for some people is not the only way to kind of construe some of this. so the /empty notion of computation doesn't really help us think usefully. Yes, I already said that. And also the social use. So some citations that you come across in the book will point to Robert Brandom and a few other people who are doing some really interesting things that almost sounded really unlikely, like bringing Hegel and pragmatic philosophy into analytic philosophy, which is really interesting. But I just watched a talk by Robert Brandom on self-consciousness, and it was really good and very kind of sober in a way, but also in its own way, sort of life-affirming and human-affirming, and capturing something that's sort of progressive about rationality and about getting more people to be rational in a way. So that kind of overlaps with politics, sort of.
Good question, Yohan, on that last
Yeah.
point. So I've only just gotten a chance to start reading the book and only now finishing chapter 1, but does Cavia end up distinguishing between what the human mind does and reason at all? Because to me, it seems like a lot of what we talk about when we're talking about, like, reasoning and logic and is not most of what the human brain and mind does in any case, right? So it feels like reasoning feels like a much more sort of formal, intentional, like sort of step-by-step process that most of human thought, I don't think necessarily like abides by any sort of like strict, logical.
He doesn't necessarily dwell on that, and because his goal is not really solving that particular issue. But I think, maybe I'm reading into it, I think he's left space for that, and definitely the people he cites have left space for that, which is like Brandom, for instance, definitely is kind of circumscribed to say that, well, we can have types of reasoning that aren't particularly logical, but they're not irrational either, for instance. And none of the citations so far that I've come across are or even in Cavia himself themselves is sort of really going the full Fodor route of saying that the whole chain from perception onwards is language like or logic like. So Cavia definitely doesn't seem to think that.
Yeah,
and
he's sort of like
perfect timing to see this sort of summary.
I think he's talking about one specific mode of reasoning that that is prevalent in some communities, and basically you can even treat this as a puff piece about that mode of thinking or mode of reasoning.
I agree.
Right.
Although, in my opinion, like if I sometimes think that he unintentionally like Cavia unintentionally contradicts themselves. Like in this chapter, I think that's happened slightly. So we'll see. That's a part of the chapter I didn't fully understand that maybe Himanshu will have some insight into. But yeah,
it does seem to me like a distinction worth making, that like what humans will come to believe there's a causal link, how they determine there's a causal link between things.
Yeah.
It's probably quite a bit different than like whether or not there's a causal link in any sort of
100%.
Yeah, I think one of the things that's sort of like, well, Cavia is implied, but what I said implied was that there are multiple modes of reasoning or thinking that people engage in at different points. This being one of them, that there's no one single mode of reasoning all the time. Like it's reasoning is not a mode. It is
Nice.
Yeah.
That's good, because like one thing that like there's a sort of reflexivity that happens when I look at all these like I've been diving a little bit into debates among the logician community, and it's weird, right? Because I don't actually know formal logic all that well, but I mean there are all kinds of disagreements and like debates about semantics and things like that, and how we ought to form things. Just like there were debates about the foundation, or still are debates about the foundations of math. So the effect that it's having on me is not so much that I want to pick like intuitionistic logic or something like that. More like, isn't it amazing that communities and human individuals have the flexibility to choose to adopt a particular mode of thinking, and it doesn't mean that they can't adopt different. So that places some really interesting constraints on the mind if you want to go down that road, because it's so flexible. Like it's so hard to pin down when you know that human beings can successfully use different kinds of logic and non-logical frames. So that's like a sort of a mystery for me, but that's like really not the topic of this book. But yeah, I don't think he's committed himself to over-claiming where reason's role is in the mind.
I mean, in any case, I think that there probably is some whether like however weak it might be, some kind of logic to human illogic.
Yeah, I mean, like there's a weird sort of predictability to certain kinds of, like, I think sometimes that I'm very good at pulling out random words or random things, phrases, and then I realized that the thing I thought was a random phrase is something I read as a child. So it's not even, it's maybe not that random. So yeah, there's a system to it. And in fact, this section on embedding, which I didn't understand, might actually be a good place to come back to this point. Because he talks about deep nets and in a way that I'm sure will be very annoying for Zoro, but in a kind of productive way. So okay, get this.
Andrea, the question.
Oh yeah, everybody just dive in and ask me things. And if there's anything in the chat that people think I should, stop and talk about, and I can't really see it at the moment, but just interrupt and tell me about it. So we.
Question.
Andrea, do you have something?
Yes, thank you.
Sorry.
Yeah, hello everybody. I guess I do have a question on the, well, you don't have to go back to the previous slide, but it's what you've been discussing. So it seems like, yeah, the idea is to kind of put meaning back into computation. And I guess I wondered why that is a good idea, because I think the reason why mathematicians tend to view like computation as kind of purely formal meaningless manipulations, that was actually like a feature and not a bug. Like that,
right.
That was that whole idea of formalism, that you can like you can reduce the correctness of a mathematical argument to just a purely combinatorial, something that was valid. Basically, the notion of logical validity of, let's say, a proof would be something that is actually independent of any kind of cognitive like semantics, but that it's really virtue of like purely finite properties of the symbols involved. And again, like a mathematician would look at the short-term thesis as just a definition of what it means for something to be computable, like what it means for a I don't know, a partial ordered set to be computable. It means you have a countable domain that can be coded by numbers, and you have a relation, a decidable relation that can be computed by an actual like recursive function, right? So the fact that there is nothing behind that, no intention, no like semantics, is kind of the goal. So I guess my question is why, why is it to put the semantics back into computation?
It's more or less analogous to the discomfort that Brouwer had with the Hilbert program. So there was it's just like a kind of intuition, right? Like Hilbert's intuition is, let's save classical logic at all cost, whereas Brouwer had a different kind of framing. But just to preempt what's going to come in a few slides, I think I've been thinking about this because I don't have a good answer because I'm not a good enough expert in the debates surrounding semantics and logic. But I think the loose answer is that once the Curry-Howard isomorphism was established, which is mainly from sort of from programs and to proofs, and so that you're giving a kind of logical semantics to the programs. And the way that happens is not through just untyped lambda calculus, but typed version, means that if you look at this triangle, whereas earlier everyone was sort of focusing on this sort of angle, if you come at things through the math logic side, then you can actually confer a semantics on some restriction of the system. And the part that I can't fully argue, I'm just going to say it because I don't fully understand it, is that without an internal semantics, you have to constantly posit a meta theory for deciding on certain equivalences and equalities. so that's the Tarsky thing, which I'll have a brief bit on the Tarsky thing. And again, I get vaguely what's happening, but I haven't really looked at model theory myself. So the idea was that, and I saw I got glimpses of this in the homotopy type theory lectures, which was that you're kind of you're either going to stipulate what things are equal at the outset or use the internal mechanisms. But there are limitations on how well you can equate things on either side of an equal sign without a semantics. So for that reason, I think, okay, that might be the right way to put it, but you're well aware that like untyped lambda calculus will produce some paradoxes, right? So that's the reason that they wanted to bring in the types. So I think that is sort of the narrative, not necessarily an airtight case, but I think that's the story here. That if this restriction on, this restriction on this part of the triangle means that this part here, and potentially even the linguistic part, if you take it in a non-Chomsky sense, gives you access to a whole sort of world that the homotopy people and the category theorists are interested in. And what this chap named sort of Gerard said is like, we can't keep deferring the meaning of our sort of statements further and further into this turtles all the way down of meta theory, but instead here we are. And I'll show you how Per Martin, there's a great paper which you recommended actually, Andrew, about type theory, which works through in great detail the meaning of every single logical operator with the semantic emphasis rather than a purely syntactic algebraic approach. And so I will borrow the motivation of those people. Let's stick with that way for now. You know, that's how I see it.
Yeah, I think my understanding is also like similar. I feel it's, but slightly different. I think what
I'm listening, one second. Go ahead.
What Cavia is trying to suggest is that semantics is best accessible through computation. I think.
Can you repeat that?
Huh?
Can you repeat what you just said?
Oh, that semantics is best accessible through computation. And I think the word they use is realizability or realizable, but I think that's
this comes from clean.
The one of the best.
So it's not okay. I guess like, yeah, you guys are both very good answers. I agree with everything, but so the idea is not so much to like make meaning an essential part of computation, but rather to say that computation by itself can actually provide a type of meaning, or like meaning in a sense, like in Gary Howard's meaning can be reduced to computation in some sense. Like, for example, like a substitution is a very fundamental operation in mathematics and in computer science, right? You have a variable. What is a variable? A variable is something that you can substitute by a value or by another expression, actually, as long as it's the same type as the variable. But if you think about it, that is so fundamental to how human mind works. Like that is actually what, you know, binding is like. It's like really fundamental to how we like create some kind of system of objects and relations in our minds. So and fundamentally, it's purely a computational thing.
Yeah, so if people want to Google about it, I mentioned it briefly, and the first or the second thing, this Tarsky's undefinability theorem or something like that. So that relates in a way to this too, actually. But yeah, that's sort of the goal. So what I was trying to say is, if we don't want to redefine what computation is, we can sort of say that what's happening here is actually a theory of computational reasoning or pragmatic computation. If you prefer to leave the word computation out and, you know, say that that's just pure Turing and devoid of meaning. So the process, which has been around for a while, and, you know, Cavia says that, you know, Kant had sort of an inkling of this, maybe even Leibniz did, is this de-semantification. So when we talk about and, oh, sorry, there's the typo there. It should be or. So when we think about and no more, we have some semantics and we can give examples of what we mean by these relations. But when you think about it from the computational perspective, all you have, if you're dealing with just symbols, is a set of relations that have no meaning and can actually be construed as either and or, depending on your semantics for whether the tomato or the banana is true or false. You can go either way. So this, in a nutshell, is why the computation itself traditionally, I mean, it's not a very long tradition, but in the past 100 years has been seen as lacking in any semantics of its own. So you have to supply that from the outside before you kind of run the computation, if you like. So Cavia has this sort of metaphor. I'm sure the people have used it as like formalization in math and in any field, actually, as a means of de-semantification, draining the semantics from a system in order to highlight its structural properties, which can be quite a useful thing. So this is this author they're citing. So that so the reasoning and the symbols are conceptually independent aspects of working with formalisms. This person that he was trying to really argue with in the previous chapter, partly because I guess their positions are not that far away, because I think Piccinini doesn't like pan-computationalism either, the idea that everything is a computation. So yeah, so this has been around for a little while, so that computation is a kind of residue, a remainder resulting from the emptying of conceptual content from reasoning, a remnant that leaves only a mechanical expression of form. So I think that's a good way of defining what formalization is, in a sense. In this context, they're kind of not necessarily building up, ironically, not necessarily making a logical argument here, but sort of pointing to some tensions that may be baked into our notions of computation. And this one is sort of almost starts just as an etymological fluke or pun, that the words automatic and autonomous almost mean the same thing, but they have very different connotations. That when we think of something as automatic, even though we're the ones who gave it, our will is what is sort of flowing through the automatic object. It's different from for a human being to be autonomous, is to kind of be a law unto yourself, if you like.
Yeah, I mean, they're almost opposites in that way, right?
Exactly. So the critique here, which I freely admit is a little dense and could probably be fleshed out more if it was an actual philosophy paper, is that the attention paid to the formal kind of almost makes the use of language invisible. Like it's like that you don't even see why we're using the language. So yeah, there's a distinction we should draw here between mechanical rule-following behavior and the capacity to alter one's own inferential abilities. This sort of thing is what we're interested in. And that's where the autonomy comes in. So Chomsky's version of this formalization is to point out the colorless green ideas sleep furiously or pink algorithms decay emotionally, is that we have access to some formalized sense of grammaticality that has no meaning. But there's something missing from this that has to do with this pragmatics of language. That why would we need all this autonomously generating formal symbols? How do they actually connect with us? Is one way to think about it. So yeah, that's one way to think about it. Why would there need to be a language without speakers? So the formal linguistics sort of differs the question of meaning. So once upon a time, you might have thought before Chomsky, for instance, that there was some real intrinsic meaning inside language, and arguably that was what inspired some notions of language as the way to talk about what's happening in cognition. Saurabh has some nice examples of how even when you leave certain verbs and nouns as sort of blanks as verbs, there is a kind of semantics. I X'd it off the table Like,
Yeah, the construction grammar folks who say that even if you are looking purely at the syntactic construction, you can, there's some semantic quality there, like
yeah,
X
yeah,
verbs Y to Z imply some motion from X to Z by Y, or
Yeah.
of Y, right? And you can, the formal linguistics falls into this trap of like, sneeze is an intransitive verb, right? You can't take an object, but I can say I sneezed the foam off the cappuccino, and no one would bat an eye. Right? It makes sense. It can be slotted into that role, but no dictionary is going to list it as being able to take objects, right? So there's a lot of interesting stuff in instructions.
yeah. So I guess the trend you could see is that someone might, not everybody, but someone might approach either logic or language or mathematics and say, okay, explain to me how the meaning got in there. And then the formalist will say, it isn't in there. It's at all. So you might be like, okay, now where do I look? So when and how do the syntactic transformations, which we agree are super useful, where and how do they come to be useful? So here's where I'm just going to sort of read this out because it's interesting and sort of evocative of argument. I cannot sort of reproduce the argument exactly. So this infinite expressivity of the grammar, which Chomsky has shown or argued for, comes at a semantic cost. So crucially, the grammar lacks any notion of incompatibility or inconsistency, which is true of math also, that you have to supply that, like what things cannot kind of go together. Absent methods of verification. So there has to be something else you have to supply. And this is a severe constraint on any semantic claims. In Brandam's view, this absence of verificational capacity is in turn a symptom of a lack of agency on behalf of the language bearer. So maybe this is like an extreme way of saying that if all the language user or bearer is doing is either churning out grammatical sentences or classifying them as grammatical or not, it doesn't particularly resemble language use. Okay, so but the expressivity of Brandam, which is a different kind of expressivity, following Sellers, highlights the role of normativity by way of deontic commitments implicit in modal elliptic assertions, without rendering these as strictly formal vocabularies, but rather broadly inferential, with a focus on their pragmatic role in agent-based reasoning. It is only through discursive acts enabled by mutually recursive recognition that agents develop meaningful utterances embedded in an environment which anchors denotation. There is no other path to semantic assent. Without such modes of interaction, one is left with a logical husk, which is simply called zombie formalism. Study a form sheared from any discursive site of cognition and action. So it's again sort of the mission statement here is that the buck has to stop somewhere or start somewhere for meaning. Like where does it come from? So yeah, it's pointing to a whole lot of stuff out there in this pragmatic kind of literature. But in the end, even the formalists, when they're asked, hey, hang on a minute, where does the meaning come from, will point to pragmatics and say, you just ask them. So that's kind of what's happening here. Way that I often put this, I don't know whether Cavia mentions it in these terms, that this idea that the formal is tautological and also potentially redundant because there's something baked into it potentially just from the outset. So Wittgenstein is the one who sort of brought this into the logic world. So it's a formula that is satisfiable or verifiable, if you like, under all interpretation. There's no way that it can possibly be false, which is often what you're taught when you learn like basic logic, just about a lot of things that are internally, intrinsically valid. So yeah, the point that Cavia is bringing up here is that there's an openness to expressivity that isn't captured by the sort of tautological sort of thing. With the axiomatic approach, what you're sort of saying, or the connotation is that you kind of already have everything that's true in the axioms, and then you're kind of just working out the necessary consequences of them. So the autonomy of the formal appears constrained to the realm of deduction, the traditional domain of classical logic, and hermetic analytic procedures whose epistemic claims are limited by their non-ampliative nature. This is a mouthful, but what ampliative is this idea that, which is actually from logic and from medieval logic, which is older than classical logic, interestingly, is that it's this classic question. When you are doing something definitely in logic or math, but even in other sort of formalized domains, are you actually learning anything? Has knowledge been increased by working through a formal system? From one perspective, which is more relying on the formal angle, maybe not. But I think what Cavia is going for, and which is partly derived from type theory, is that type theory, intuitionistic logic initially, which then kind of strongly influences type theory. Instead, the combination of these two sort of highlights the moves you're allowed to make rather than the axioms. And then you're allowed to sort of provide premises, like initial points for argumentation on the fly, and also build new types. So one of the things that Cavia will keep returning to is this idea that the freedom to build new types is the kind of ampliativeness that offers a certain creativity and autonomy to the logicians and mathematicians, and to the extent that human reason in less formal domains also has some sort of autonomy like that. We're doing something analogous to making up new types on the fly, dependent types, if you like.
How many slides you got, Yohan?
We're sort of halfway through.
I
I'm
don't
going
want
to talk about type theory and yeah.
Okay. I don't fully understand this point. Like, it seems unusual to me to want to determine the expressivity of a language in some way by the sort of, let's see the phrase, by the agency of the like users using it, right? Like, first of all, is there any reason to believe that any of the class of natural languages, or let's say even context-free grammars, would leave any agent like using the language any less capable of producing an utterance, or unable to produce or express something that can be expressed in one of the other languages?
That's a good question. I don't know the answer to that, because it talks a little bit about these formal grammars and things, but I didn't quite
Can you say that again?
understand.
I don't think I fully.
Well, so like
the
they're
question.
saying, let's not conflate the expressivity of a language, which is normally defined simply by sort of like how its generative capacity, right? But instead to say it has something to do with the notion of agency in the form of pragmatic linguistics, and agency in turn weirdly should not be confused with the autonomy of a language. Like, I don't get this point, because we shouldn't refer to the expressivity of a language by how capable the users using it are. And even if we were, is there any reason to believe that any of the natural languages, or even context-free grammars that could have been some not yet existent natural language, is there any reason to believe that any of them aren't as expressive as any of the others? Right? And to all evidence, I would say no. Basically, we have no reason to believe that any one language renders its users like less able to express certain ideas or whatever than any other language, right?
But,
Mhm.
but
Well,
just as a
certainly,
path-
sorry.
Jesse, yeah.
Certainly, if you bring pragmatics into it, I mean, there's like a issue of constraints there, right? Like, you know, so it certainly could be the case that under certain constraints, one language is more capable than another. No?
Yeah, and in formal languages, this is definitely true. So for instance, I cannot tell you the names of exactly who and what did this, but there are, when they were confronting in the Gödel era, right, there were different ways of like trying to weaken formal theories so that you could not express anything like the Gödel sentence in that language, so that you could then get both consistency and completeness, for instance. So you can, in formal languages, talk about expressivity in a very formal way, like and show that certain types of constructions are not expressible. But you're right, in the pragmatic world, I don't know what that means any longer. So to some extent, what he's just contrasting the way that one talks about expressivity in the purely formal versus it's almost like he's pointing to this space as he gets there eventually, that type theory is kind of trying to get at, which is that even before you get to natural languages, there's a way of talking about the formal that highlights this expressivity.
Agreed. So like you have languages
like,
that.
Sorry, I was going to say that I don't think the implication here is that of using this sort of expressivity as a measure of a language. It's more of like saying that don't use it as a measure of a language, right? Like just because a language has a few more like devices or dimensions, for lack of a better word, that it may be more expressive. Because
okay, now this helps me understand something in the chapter that I didn't understand, but we'll get to that in a sec. I'm glad you said that so much.
So take a context.
So he's like, yes. So actually, where he gets to eventually is this idea that a language that does not have the formal expressive capabilities of a more complex one in the Chomsky hierarchy, for instance, can do something. It is some technical term, and at the time I read it, I couldn't follow what it meant. But it's in this conceptual embedding, sorry, the bootstrapping section, which is the idea, which is trying to sort of formalize what maybe Sorrell was getting at, which is that you can actually invoke something that you didn't understand. So he has this metaphor of like a coach being able to instruct an athlete who's much stronger and faster than they are. Even the coach doesn't have the same abilities as the athlete. I never really understood what was happening in this, so I think this now really helps with that. So sort of what you're saying, I think, does actually align with what maybe you're getting at, that the formal restrictions on expressivity don't necessarily map onto the pragmatic restrictions, maybe.
Well, so at a minimum, it would be worth distinguishing between the expressivity in a formal sense and then the constraints that are brought in when you bring in pragmatics, right?
So he's trying to do that. So I didn't. He had a whole diagram with the Chomsky hierarchy, which I didn't fully understand why it was in there, so I didn't bring it up. Like, so there's this section on page 84, and he's trying to talk about how this is like each one is more expressive than the one below it, and is capable of expressing the corresponding. The generator can generate a particular thing. So the recursively enumerable can generate a Turing machine, that sort of thing, right? So I didn't quite know why he brought this up, but I think it was to answer or to talk about this topic that you brought up, and which I think Himanshu can shed was helping with. So we'll get to that. I have some quotes about this bootstrapping thing, but yeah, that's all. I mean, like, I think it's right that you shouldn't use the formal expressivity as a substitute for the pragmatic. Maybe that's what he's getting at. I'm not 100% clear on that.
Okay.
So
it just seems weird to me, like take a context-sensitive grammar like A to B and B to B and C to B N, right? There's simply no way to create like a regular grammar that will generate those sentences or accept, the set of sentences produced by the context-sensitive grammar, right?
yeah.
And losing the ability to refer to that simply because you want to talk about the expressivity with regards to the notion of agency in the form of pragmatic abilities seems, yeah.
I agree. Maybe they are orthogonal, and maybe that's sort of relevant. So there's bits which I didn't know how to talk about, which maybe we can get to when we get to the bootstrapping part. But yeah, I'm not committed since I don't fully understand what's happening now. So yeah, so he's sort of diving into this should truth be outside. So in a pretty standard approach of the formalists, truth becomes anonymous. Well, okay, so this is the contrast. For the intuitionists and the constructivists, truth becomes synonymous with the method of constructing a proof, in contrast to Tarsky semantics, which are pretty popular. which relies on meta-linguistic apparatus. So there's a hierarchy of languages that give you what things mean and how to make equations, basically. Tarsky introduces the notion of a meta-language to semantically frame any given formal system in an attempt to ground its truth values. An abstraction leaking ever outwards in an eventual appeal to natural language for the meaning of primitive logical operators. So Gerard, this is the person who came up with something called linear logic, which I hadn't really heard of until I read this book, and it's a whole rabbit hole of its own.
Gerard actually discovered the paradox in Martin Love's original type theory, where
okay, cool.
Where the type of all types was itself a type, and it's Gerard's paradox is kind of a very surprising, like it was a kind of like naive type theory. So just like Russell discovered paradox and naive set theory, Gerard kind of discovered the paradox and naive type theory. And what's interesting about that is that like a consequence of there being a paradox in type theory was that version of inconsistent type theory was actually Turing complete. You could actually implement any computational process in that language, and these things always go hand in hand. Like if your type theory is inconsistent, there is usually like a looping combinator, fixed point combinator that you can use to implement arbitrary recursive functions. And conversely, if your type theory is not inconsistent, then the least things it will not prove that it's strong normalization, because that proves its own consistency. So by Gödel's second incompleteness theorem, it cannot do that. And so you actually have an exact function, a computable function, which cannot be implemented in that system, which is the function that, given a language, given an expression of language, computes its normal form. Like that, basically, like a consistent type theory cannot simulate itself, and if it can simulate itself, it becomes inconsistent. But if it is inconsistent, it can simulate anything because it's Turing complete. So it's kind of very. There is this interesting connection between like paradoxes and Turing completeness, and in a way, it's the fact like there is. I guess it's related to like the computational reflection and logical reflection, right? Like universal Turing machines is a kind of computational reflection. Like you have you can basically like a code, you have a program that like can compile arbitrary program, but logical reflection is kind of like the system talking about itself, like in Gödel's incompleteness theorem. And so if you have like, basically, if your logic is expressive enough that you really are universal, then you become inconsistent by Gödel's incompleteness theorem.
That's cool. We talked briefly about this because he mentioned some of these sort of build-ups, because one of the narratives in the first couple of chapters is that this sort of interesting irony of history, that the way that computation is born is sort of out of the negative answer to the quest for certainty. Like a certain sort of like Hilbert's and Scheidung's problem, which is the decision problem. Do all mathematical questions have an answer, like a true-false kind of answer? And all these proofs came out within the same decade, right? Within a few years of each other. First Gödel, then Church and Turing. All with a negative answer to these questions. Well, Gödel's is not the same question, but both Church and Turing had negative answers. So that's really interesting. And the bit about reflection, you can't help but think it has some sort of deep metaphorical meaning even outside of these formal domains, but maybe that's too much of a tangent. But so Gerard, but I've been reading some of his recent stuff. He's a really, really opinionated person. It's very funny to read these papers of his, but he rails against this appeal to meta-language as essentially a cheap trick, pushing semantics ever further from logic, passing the buck, so to speak. You asked for money and are paid in meta money, he remarks in exasperation. So that paper, where that comes from, is quite a paper. I don't fully understand it, but it's really intense. In seeking an alternative to Hilbertian formalism and its accompanying semantics, Gensten has instead developed a deductive form of verificationism. The meaning of a term can be said to be verifiable via the inference rules internal to the language. And this is the bread and butter of constructivism, and you see the modern iteration in type theory, and specifically homotopy type theory, that the truth of something is the internal ability to witness proof of it. And Gensen, so when in fact, they teach Gensen's natural deduction. They taught it in that homotopy introduction. So you can get if you're interested, you can learn about it. It's sort of like, if you already know a little bit of logic, it'll seem familiar. It's just sort of making very, very explicit every single move that you're allowed to perform. And the reason that he introduced it, Gensen, in the 30s, I think, was because he was not very satisfied with Hilbert's version of formalism. That if you look at it, it looks really painful to work with Hilbert's version. And so they were like, let's do something that resembles how mathematicians think a little more. Although it's still a little stiff compared to what mathematicians seem to do. So just to sort of link this to what exactly they're talking about here, Tarsky's theory of truth, it gets made fun of a lot, even though it's restricted to formal world. It's this idea of that statement P is true if and only if P. Snow is white is true only if snow is white. It's amazing, but for a long time, this was the best a lot of people could do in that formalist world, which is to say that there's a meta language in which you have to assess whether something is true. It frustrates a lot of people, but it's still a very, very common approach. And constructivism is like, no, we don't need to do all that. We can construct our truths internally without having to jump out of the system. So here's a sort of strand that comes up a few times. So as I will show in the next section, a constructive way of viewing this claim is about the creativity of logic. And so there's this dialectical kind of quality of thinking, which now in logic has again been sort of more formalized. So there's a game semantics of logic, which again, it's Girard who's come up with it. It was a little over my head, so I didn't quite understand how it works. And if for instance, you want to start looking into modal logic, there's a sort of game version of modal logic that you can play. So it's a two-player kind of system. And the way that Girard describes this sort of game semantics version of logic is that rather than people having to invoke like a kind of god of the system in order to establish truths, or a referee, like the game doesn't even need a referee, you just need two players. This is really an interesting thought. So yeah, this is just an example of the kind of thing that happens in natural deduction. So this is AND introduction, which is the idea that if I have statement A and statement B, and in this you're kind of asserting it, you're not simply just saying that it exists, just asserting A and asserting B, and you draw a line and say that having asserted A and B, I am allowed to assert A and B. And then you have an operation that's AND elimination, which is the opposite, which is how do I get rid of an AND statement if I want to do something else. If I happen to know A and B, then I'm always allowed to sort of use a projection operator in the category theory language to have an A, and I can also have a B. So that's the other one that you can do. So all sorts of operations and all sorts of types in type theory will have at least introduction and elimination operators, and also sometimes a computation. So there's a few other kind of moves you can make, and they all take this form when you're not looking at a specific programming language. Yeah. So this is sort of where they're pointing with the expressivity, which is that you're not constrained as Hilbert was, or coming from Frege's kind of tradition, to only the self-evidently true things. You can suppose whatever you like over here and at the start. And I think that's so having been presented with a bunch of types, you're always allowed to kind of create a derived type. As people who program in a functional programming language, like in Haskell, this is the sort of thing you can do, make new data types. So that is sort of what's happening here. Connection with dialogue, I don't fully understand, but it's also been quite formalized.
Is there a mention of dialogic in the book?
What logic?
Dialogic?
He cites this Brazilian name or Portuguese name, Dutil Noves. somewhere here. So there is something, that person wrote a book called The Dialogical Origins of Logic, I think. But yeah, and they might mention game semantics, though, not necessarily in this chapter. So just to show that this is like, there's a sort of history to this paper, which I highly recommend. This is a really, really good paper on the meaning of the logical constants and the justifications of the logical. Andrew told me about this. And so he just works through it. The first several pages are sort of philosophy of things that seem almost trivial, but then you kind of have to go through them because it gets abstract very quickly. But the goal here was to show that you can study the meaning of logical constructions without having to decide on the truth external to the system. So you don't have to do this meta mathematical trick that Tarsky would say that you have to do. So this is the sort of story here. No longer do we need to prove anything. That is, no longer do we need to prove meta-mathematically that the proof figures, divested of sense, reduced to introductory form. Instead of proving it, we endow the proof figures with sense, and then we see it. So this is the kind of re-semantification move, if you like, kind of coming away from the formalist tendency. So here again, I couldn't dig into what he exactly meant by this, but the definition of convertibility or computability and the proof of normalization, which I don't fully understand, but have been transposed into genuine semantical explanations. And you know, if you just spend the time, you will see them. Like it's a matter of just working through what they mean. So that's kind of a really this is a good paper on that topic. So this is more or less the style here, which is rather than deferring the meaning of something formal, you say, look, you can catch it in the operations themselves. So this paper does that pretty well. And in the end, it's just what anybody already thinks when they're introduced to and or anyway, and like sort of what's been the case with like medieval logic and even before. It's just that right at the end of the 19th century and in the beginning of the 20th century, people went down this formalist path, which is not we don't have to reject it. Like there are uses, but there's something potentially powerful about this that interestingly enough relate to computers, where you'd think because everything is automated, why do you need to care about semantics? But even here, the kind of design of programs, algorithms, and sort of fault tolerant, like why do people use strictly typed languages, for instance, and why is that sort of closely linked with functional programming? There are pragmatic reasons for it, and they have to do with the way in which you can catch errors, but also the way in which you think about the problem can change. So I've said this before, but again, I started using Julia, which is not a strictly typed language, but I was almost immediately I started defining types for some neural networks I was implementing, and I was talking to Himanshu about this, and he had this point that compared to my sort of crappy MATLAB code, where I was implementing the exact same differential equations and networks, you'd probably, as a sort of reader of my code, learn a little bit more about the kind of conceptual dependencies of actual brains from the Julia code, because you'll see that, well, networks neurons can have other components, and the components can have currents. So there's a structural kind of logic that has meaning, if you like. So there's something that is being injected into the way people design their programs. So which leads me Stanford Encyclopedia has pretty good agents, and so this is the story, intuitionistic type theory. So you get from Brouwer to Haining, and then so it's called this BHK interpretation, and Per-Martin-Löf was Kolmogorov's student. So there's a direct line, and from there to kind of modern sort of type theories that fixed all those problems. So intuitionistic type theory is a new way of analyzing logic through its introduction of explicit proof objects. This provides a direct computational interpretation of logic. So this is what we talked about before, since there are computational rules for proof objects. As regards expressive power, intuitionistic type theory may be considered as an extension of first-order logic. And the story for why this, I think, people here probably kind of know this to some extent, at least, the set of all sets, type of all types. So there was a reason why type theory came up initially with Russell. And most of us, I guess, are aware that they're pretty useful in programming. And they're around even in programming languages where they're not sort of focused. So again, here in this page, they talk about the semantics issue. In a standard presentation of first order logic, you use this Tarsky picture, whereas intuitionistic type theory has this Brouwer-Heiting-Kolmogorov interpretation. So the symbol people use for A implies B is a method that transforms a proof of A to a proof of B. That's what you have to provide in order to say that A implies B is true. So whereas Tarsky semantics is usually presented meta-mathematically and assumes set theory, Martin-Löf's meaning theory of intuitionistic type theory should be understood directly and pre-mathematically. That is, without assuming a meta-language such as set theory, which is seen by a lot of people as a feature. And that sort of naturally connects to this topic of the Curry-Howard or isomorphism. So this is back to Cavia, and so on the left. So to mark out an expression as realizable, which is Kleen's way of talking about the same idea, is to issue strict verificationist constraints on an alternative proof theoretic treatment of the category of the possible. For now, we should point out that the insistence on the realizability of truth proceeds from a distinctly computational stance on logic, committing it to provide the methods for its own construction without appeal to an external authority, grounded instead in the induction of inferential rules. Yeah, it's pretty clear why. So it's like you don't have to go hunting around somewhere else for why something is true. It's provided inside the theory. And a lot of this, I don't know how. I guess it's sort of useful, but it's something that people are pretty excited about. This Curry-Howard correspondence, also the Curry-Howard-Lambeck correspondence, because there's some map to Cartesian closed categories also. Is this idea that programs have a correspondence with logic? The way to make that work, though, is via the programs have to be in a strictly typed language and obey certain constraints. But once you do that, you can treat all propositions as types, and the proof would mean that your program basically type checks. And you can get a glimpse of that in these, homotopy lectures, and it's pretty cool actually. So again, the verifiability is the criterion of truth rather than somebody checking from outside. And this is an intrinsically computational perspective on logic. So that's like most of what I understood. The chapter ends with this stuff on expressive bootstrapping, which I didn't quite understand. And it comes from this sort of what we were talking about just now. So a language is not limited in saying what it is to one to have. I can never parse that sentence. Language is not limited in saying what it is one has to do in order to bear additional capacities. So I think a way of talking about that formal issue. He gives the example of a sports coach advising a professional athlete. Coach need not be endowed with the physical ability of said athlete in order to know what it is they have to do to improve their performance. So this is interesting, right? There's a slight tension with this intrinsic meaning idea, which is, but maybe not. So it's like the idea that my abilities in a formal sense may be limited, but I can almost like label certain things that I kind of trust someone else to do. And then I sort of close that loop pragmatically. I think what's happening here. So random conjectures that there is no reason why, and this is maybe Sorrell's point, that low-level automata cannot bootstrap their way up the hierarchy of grammars using such techniques of pragmatic elaboration. I think this is exactly what Sorrell was saying. The physical limits of said logical capacities can instead be overcome by rendering artifactual those resources that are required to attain the abilities in question. So basically, what I just said, sort of like having a label for something that you yourself don't understand in some sense, or that you can't verify yourself. But it's sort of like the ideal of collaboration, right? It's like, well, I cannot necessarily prove this, or even understand the proof, but I will sort of route through my social structure in a sense. And that's, I think, what Saurabh and Himanshu were talking about before. So then he kind of gets to this point where he takes that and runs with it right at the end of the chapter, in a way that I'm quite ambivalent about, but it's a fun topic. So one can view the project of AGI through the pragmatic lens. Humans enacting expressive bootstrapping via models which perform feats entirely incommensurable to human reasoning. So take any search of the take any search of the World Wide Web as an example. An ensemble of models is summoned to navigate a graph representation of billions of nodes representing documents in order to infer relevant information in a dozen milliseconds or so. So it's sort of like a cyborg thing. So one could equally consider the translation ensemble of artificial neural nets capable of instant two-way phrase mapping between all existent natural languages, or else a language model fed more text than any human could cognize in a lifetime. Each of these models embed linguistic concepts in a high-dimensional space with no neural correlate, exhibiting its own digital geometry, the topology of which I argue represents an internal inferential logic. This is the big, bold, philosophical, almost ontological claim that he will.
This distinct geometry.
What did I say? Distinct geometry. And so I'm saying this is kind of Cavia's big point, and where he gets to the sort of topological story. These forms of statistical inference are executed within a recursively enumerable grammar corresponding to a finite enumerable operation, but call into question the relation of natural language reasoning and its associated speech acts to computational reason. So I think what he's saying is that, and he gets here to this idea that going through the translation loop, meaning that we often have argued that deep nets don't understand language, right? And the way we say that is often the deep net in isolation from people using it. But if it is receiving, like if GPT-3 is receiving linguistic input, doing whatever it's doing with its matrix multiplications, and then coming back into the space of language, then even if that whole thing is a black box, there is a sense in which we are using it an inferential engine, so that it's providing a space for navigation. So we kind of give it the sense in which it has linguistic capability.
So just to tie this back to the previous slide, would you then say that the human who's making the search or whatever is the coach, and then Google's ensemble of models is the athlete?
Right, 100%. Yeah, that's exactly the analogy now. And so I dug into this essay that he wrote, Arity Abstraction, that they wrote. So which gets into this topic a little more because it's a little thinly sketched out in this year. But so this is again kind of like so Reza Negarstani is a bit like this too. It's sort of philosophy 2 steps from science fiction in a way, like, or it's like the ideal philosopher for a science fiction universe, if you like. Nevertheless, contemporary AI confronts us with modes of statistical inference that lack explication. This we know, it's the whole explainability issue, but exhibit validity within domains marked out by human epistemic classes. Again, that's just a way of saying that performance is good. An open attitude to inhuman reasoning might instead view the semantic void at the heart of AI as a result of linguistic incommensurables arising from a process of abstraction. And in the book, and maybe even in this essay, he uses a diagonalization argument here in a way that is quite obscure to me. But the idea being that there could be, like in the literal Cantor sense of incommensurability, there's a expressivity here that does not actually map onto in a one-to-one way with our expressivity. And that is sort of one version of abstraction. That abstraction as a practice of mapping between domains introduces a challenge to a theory of language in the realm of representation, namely providing an account of how cognition transitions in and out of the properly linguistic conceptual domain. So kind of reflecting back on the brain even to some extent, because we don't know how we come up with the next sentence either, right? Like, so what's the difference between me summoning all my knowledge that is sort of embedded in my biological neural network, and a person sitting with GPT-3 and making inferential moves. I think that's what Cavia is going for here. So later on, he talks about embeddings again, and that's it comes up again later. But embeddings are not limited solely to natural language. Any input domain can be collapsed into a common vector space, this like word to vec, as evinced by models which combine image and word data into a single embedding, blah, blah, blah. Uncode, yeah, okay. These acts alone are not evidence of language formation as such, fair enough, but rather a capacity to abstract both the syntax and semantics of existing vocabularies into a novel encoding. I think I agree with that. I think that's right. It is in transitioning out of embeddings back into the input domain that we see how they constitute internal languages. And again, okay, and which is the controversial part. Like, are we allowed to call something that we cannot understand an internal language? Well, yes, for the same pragmatic reason that we can say that another person has the faculty of language, because we don't know how they do it, and we don't know how we do it either. To take, for example, translation ANNs that are able to translate between language pairs that they were never explicitly trained on, indicating an internal interlingua with a strong claim to the status of language. So provocative and definitely worth pushing back against, I would say, but interesting. Like, it's arguably one of the more interesting things that I've seen, and it came long before that silly lambda debate. But it's kind of cool. It framed it in a way that is a little fresh for me. So that's it for what I have.
I just want to comment real quick on the inhuman reasons part. I don't know that it's inhuman, given that we don't know how language works and how we're doing language, and given that actually GPT-3, the internal activations of language models, like these massive transformer models, are actually the best predictor of brain activity during language comprehension.
Right,
So it's
you said that last time. Yeah.
So I don't know that we don't have these internal embeddings, and there's this. These acts alone are not evidence of language formation as such, but rather a capacity to abstract both the syntax and semantics of et cetera. I don't know that we don't do that.
Yes, I agree. I'm with you on that. Like you cannot say that humans are completely different. At best, you can say that by the same token that the validity is proof that it is something like language, the failures, the ways in which it drifts away from normal abilities, makes it seem inhuman, and that will change over time. So I'm with you on that. Yeah, so we should I just put that there as a sort of, and I think even a lot of people in this world, continental philosophy, will just sort of throw that out there as a provocative thing, but I agree, it's not necessarily that inhuman even.
Isn't this just a modernized version of a Turing test, though? Isn't this just basically restating a Turing test in a different way? I don't see
that's fair. And again, it's like Searle's Chinese room. So yeah, yeah, I suppose it's just a different way of talking about that. But how that relates to the internal semantics of computation is unclear to me, because when we have successfully reasoned using whichever tools we happen to have, we know about what the moves are. If it's the public use of reason, right, the classic reasoning, we can justify each step either using a meta language or with moves that each sort of intrinsically have semantics, like when we typically make moves. So here it is not yet it's not the case that any of these devices are capable of reasoning, because they don't have that reflexivity. But who knows? I don't know whether it was here or somewhere else. There was this talk about, who was it? I think I saw this on Twitter. Someone talking about Judea Pearl's critique of these networks is that they don't have any grip on causality. But I was thinking, as soon as I read that since now causal networks have a mathematical and very operational way of you can train them, or you can at least posit them. You could imagine a system that has been maybe even pre-trained and then supplemented with some kind of causal network that then sort of queries itself, like queries its own internal representations to then provide answers to causal questions.
You'll fall into the same trap as with humans, though, right? Like basically asking for an explanation of why you believe the thing that you believe. People will, even if they don't have an explanation,
right.
will make shit up, right? And you can, in training a network to do that, you'll probably do the same thing. But I think the same critique applies to what Judeo-Pearl says about these networks to humans. There's no reason to, you can't point to anything in the human that says they're extracting causal relations as opposed to, you know, purely statistical ones and so on, right? Like, you know, the same inability to point at a neural network and say that doesn't really understand causal relations. You'd probably be able to point to most humans and be like, neither does that.
Yeah, but at the same time, just technically, it would be really interesting to kind of supplement these systems with a kind of imagination, right? Which is like to kind of do counterfactual reasoning on their own encodings, you know?
There's almost a number of ways in which some aspects of that happen. So like models that sort of hallucinate like in a reinforcement learning setting where they'll just imagine what it's like to go down a particular path.
Yeah.
So you build world models that, you know, it's essentially first you imagine it, you can then actually replay and so on and so on. But the thing, there's a number of things here that I do have beefs with. Like,
good, go for it.
So
I
one,
don't, yeah.
The embeddings, you can encourage a model to learn to embed into any arbitrary space, right? So the reason that the embeddings here seem to capture something about the syntax and semantics is essentially because we've encouraged the models to learn something about the syntax and semantics. Therefore, you would expect for the embedding to reflect some aspect of that. Otherwise, it wouldn't have been able to carry out the task in the first place, right?
Right, but then there's the point which someone was making about the predictive aspect for the human brain, and you know, I don't know, like Karthik is not here, I guess, but the point that he hates it, but you know those brain score things about visual cortex and deep nets, like I don't hate it as much as Karthik does. Like I think that there's something there, like it's maybe a fluke, but the more you make these alignments, it seems either that you're learning about the brain, or that you're learning that the brain is a good, or that simply giving something a large number of degrees of freedom doesn't mean that it's going to find a completely wildly different solution.
No, I agree with that.
Data set is the same, you know.
In fact, I think the only way it's able to perform so well is by learning something that better and better approximates some aspect.
That's sort of the other extreme. I don't know about only way, but I definitely think it's something worth looking at. You know, like
I think, for example, like you could probably show large classes of statistical models when improved and structured in a way that would allow you to predict something about human brain activity while processing sentences would actually show largely the same results, almost by necessity, right? Like in the same way that like it's sort of necessary to have edge detectors in a model that learns to do vision, because it's sort of like a requirement of the thing that we're asking the model to do, to segment and so on, right?
Yeah.
So
but we have not, I mean, like we're nowhere in the domain of like making a proof of necessity, right? Like it's simply too complicated.
Agreed.
Right?
It's purely an assertion. It's purely an assertion.
Yeah. So I agree with you on that. So but it's when you don't have a proof, it's not satisfying, right? Because you always think, well, couldn't there be multiple ways of solving a problem, right? And you kind of experience that even among human beings, right? That, oh, this person did it in this way and this other person did it in a completely other way. At least at the description.
We don't have edge detectors, right?
So again, what?
We don't have edge detectors, right? So we have found a different way to solve the problem. So
I mean, only if you agree with Steve, right? Because some people don't make a distinction between contrast detection and edge detection.
Yeah, I
So-
should have paid more attention in those machine parts.
Wait, hang on a minute. Do the machine systems make edge detectors or contrast detectors?
That's a good question. To be honest, I
I
don't
haven't
even
looked
know.
at that term.
Yeah.
Because that in that word, people rarely make the distinction.
Mhm.
So
I have a question. Hello.
yes.
Yeah, so this is an interesting idea that the semantic voids of the heart of AI is a result of linguistic incommensurables. So basically it's saying like, what if there is like an internal language that we just cannot map onto, right? Something like that this networks use. Why does that have to be a language? Why does that so why is every represented knowledge necessarily represented in a language then? Like what is a language then?
It's a tough one, right? I'm very ambivalent on, because whenever we talk about structure of the structure of language in the sort of Chomsky sense of whatever is left of universal grammar, right? We're talking about like however sophisticated the theory is, the superficial behavior of language, like whatever we can collect and document and do studies of, right? But we all know that the way in which one gets to from one sentence to the next, or one phrase to the next, is not even modeled by any of that. So as long as we have two black boxes, one in the human and one in the machine, we don't have any criteria by which to say that the black box is the capacity, right? Does that make sense? Wait, it's this old tiny room again, right?
Maybe this is slightly off topic, but I've said this maybe before, but I do think like, we don't do linguistics enough justice. Not in the sense of like solving the language understanding problem, but like they know that like semantics is important and pragmatics is important, and sure, like the syntax has been the point, and they know that there's like internally much more complexity, but the idea is like, in given the output of human language, what can you understand about it? Under those constraints, and how simple of a description can you make? And then given that simple description, then the question is like, it's a separate question of like, how is that created? But that endeavor in itself like leads to different implications of how things might be done internally. It doesn't only just describe the surface. I mean, the emphasis is on the surface, but the thing is like, you get to a certain point where like syntax can only take you so far, and semantics, there's sort of like two different kinds of semantics too that we're kind of brushing over, I feel like a little bit here. And one is like the contact with the world, the relationship with the world, and the other one is like how things are like combined together, which also then after they're combined together corresponds to the world in pragmatic ways. But there's sort of like different levels of semantics there, and I feel like it's somewhat important to make some distinction there. But yeah,
sometimes in linguistics they separate semantics and pragmatics, right? So that's another thing to keep in mind, I think. Because in logic, they don't typically talk about pragmatics. They just talk about semantics and the syntax.
But when I like took the like linguistics in Yukon and did the way they do semantics is basically type lambda calculus, which is basically meaning that the idea is that all natural language sentences you can think of them having denotation in some kind of model of high-order logic, or it can even be first-order logic, like you can have individuals, predicates, relations, and the quantifiers, and like basically do a lot of language just that way. And I do think that like just if you update the meta theory of that approach to something like dependent types, you would definitely capture a lot more, like your semantic, the semantics would go a lot deeper in terms of capturing the actual relationship between things. I assume that the AI people didn't really get to doing that yet, but probably you could get a much better language model if you did try to at least have some kind of semantic, if you didn't just do purely syntactical things.
I think it's
also
only a
did
matter of time, right?
semantics.
I agree completely. Like just what little exposure I've had to the type theory, you can tell that how much I don't know, the power of it, that like how much meaning you can actually encode in this is quite a lot, I think. I'm quite impressed with it. I'm sure that natural language will stump somebody on something. But
According to the slides that you just the citations you just displayed, all mathematics is at least can be fully captured the meaning of
yeah, so I
by
don't know
just by type theory.
Well, to be a good constructivist, it's like not clear to me how much of all of mathematics has actually been constructed, but the project is ongoing, right? Like, because the one comment I've seen, which is true of a lot of these sort of formal systems, is that a lot of the time when a new formal system arises, a lot of the work and the theorem proving, etc., is about the system rather than about like making all the sort of contacts with every other branch of mathematics. So I'm sure that more and more of it is happening, because I think in the last couple of decades, people have become more interested in automated proof, proof helpers and things like that. So it's changing. Things are changing rapidly. But yeah.
Well, I think if you, I don't know. I guess my view on that, it's like if you do like really radical constructivism, basically like Curry Howards, like if you just like use a system like Coq where like everything computes, where you don't use any axioms like exclude middle or anything, like every single proof can actually be ran, like executed, then that is actually that's probably the mathematics of the future. I mean,
I agree.
Over time, classical mathematics, more and more of it will be kind of constructivized. I mean, this has been going on for like the past centuries, and there is a big chunk of like modern algebra that can be done completely constructively. A lot of category theory can actually be done constructively.
Yeah.
But I think that it's not. I actually don't at all see it as a fault. Well, insofar as it is a deficit of like the type theoretic based foundation of mathematics, in that it doesn't yet capture all of modern mathematics. That's more like a cultural thing. Like eventually our culture will advance to the point where we will not see that as a problem anymore. And
yeah, it does seem like
that's I guess the modern view of like type theory as a foundation.
Like we had a little bit of an exposure to AGDA and theorem proving and stuff like that, and I thoroughly enjoyed it. Like it was great. It was just
that's awesome. Like that you really see that like proving is programming. You just write in functional programs, and the proofs are actually much simpler. That's right.
Yeah. There was there's some weird
and
things.
You can run every proof. Literally, you can run everything.
And what's cool is watching like the interaction. Like these homotopy summer school stuff is online. The videos are all on YouTube. So if you're curious, like right from the second lecture, they start showing you AGDA, and you see right to the get-go what it means to like work with one of these things and how the types help with that. Because like what you do is like, if you've ever seen a proof, you know that there's all these steps. So what's really cool with what the mathematicians do both on pen and paper with natural deduction and AGDA or Coq, is that you start with something you have at the beginning, then you likely leave some blanks, and then you say, okay, I want to get here. So stuff that people do informally, which is like work backwards, you actually see them doing it, and then they sort of enter the hole, and then they say, well, now that I'm in this hole, what are my sub goals? And if I have all these sub goals, what do I have that I'm allowed to use to prove that sub goal? It's beautiful. Like the way it works is really beautiful. So yeah, there's a lot of stuff happening there that I think is pretty powerful.
And it's also like what's really cool about AGDA is that it actually shows you how a really strong type system, like there is almost some semantic automation built in, because you will sometimes like you are in the hole and it tells you you need to construct a term of this type, and just like these are the things you have in your context that you can use, and you try to write something, and then it tells you, no, this is not what you wanted to write. Here is what you really wanted to write. And the reason why it says that is because it's actually understanding like logically on a deeper level what it is you're trying to, like what your proof should do. And And so
Yeah,
it just shows, I think a really strong type system can go such a long way to capturing like logical relationship. Somebody should just try to like learn the, I don't know, the hot library, like try to learn a neural network to construct all
Holy
those
moly.
proofs by itself.
Yeah.
And then try to use it to solve like some open problem. Synthetic quantitative theory.
Yeah, recommended. I'll stop the recording and we can chat a little bit more.